Hello students, welcome to the Department of Collegiate and Technical Education. As a part of Learning Management System, we are taking classes of 3rd semester students of Computer Science and Engineering branch on the subject Computer Organization with a subject code 15CS32T. In this session, we are going to discuss on Unit 5, that is the memory system. In that, the topic basic concepts. Before start with the actual session, let us recap the content that is made in the previous unit. In the previous unit, we have discussed on how to accessing I/O devices, interrupts, enabling and disabling the interrupts. Then we discussed on vector interrupts, interrupt nesting, and here we are already discussed about how to handle the interrupts when multiple devices are sending those interrupts. Then exception, direct memory access, bus arbitration, and finally interface circuits. So these are the topics which have previously discussed. So I hope you all understand these concepts very well. Now we move on to the today's session. So the objective of today's session will be memory, the types of memory, basic concepts of memory system, connection of memory to the processor, and other forms of memory. In that we are going to study cache memory and virtual memory. Let us discuss these topics one by one. So first is the memory. So what is memory? So memory is nothing but it is a storage device. So this is also called as a storage device and it is one of the functional unit of computer system. So this we have already discussed in the first unit itself. So memory is used to store program instructions, data and results of computation, etc. So it is a storage device. That's why we are going to store all the data, characters, informations, operands and any results, etc. Whatever the information is there which is required for the further operation. So all those informations are going to stored in the memory. So in the memory, there are two types. The first is primary memory and the second one is secondary memory. Primary memory is made up of semiconductor material which consists of large number of storage cells and each cell is capable of storing one bit of information, either 0 or 1. It is also called as internal memory or main memory. ಈ ಪ್ರೈಮರಿ ಮೆಮೊರಿನ ಮೇನ್ ಮೆಮೊರಿ ಅಂತಲೂ ಕರೀತಾರೆ ಮತ್ತೆ ಇಂಟರ್ನಲ್ ಮೆಮೊರಿ ಅಂತಲೂ ಕರೀತಾರೆ. The best example for primary memory are ROM, that is read only memory, and RAM, that is random access memory. So we can see the picture of primary memory here. So RAM and ROM. The second one is secondary memory. So secondary memory is a permanent memory and it is made up of magnetic materials and it is also called as auxiliary memory or external memory. So this memory is used to store large amount of data. So we can see the example of secondary memory here. So CD, DVD, hard disk, floppy, pen drive, etc. So these are the example of secondary memory. Okay, now we'll see some of the important difference between primary memory and secondary memory. So primary memory is also called as a main memory or internal memory. So secondary memory is called as a auxiliary memory, external memory. The best example for primary memory is RAM, ROM, cache, PRAM, EPRAM, etc. The same way, the example of secondary memory is hard disk drive, CD, DVD, floppy disk, flash drives, etc. Then the primary memory stores the data temporarily, but the secondary memory stores the data permanently. The primary memory is volatile in nature. The secondary memory is the non-volatile memory. That means volatile means the memory it loses its data when the power is off. The non-volatile means the memory remains its data even when the power is off. So this is the difference between these two. And the access data, that means CPU will directly access the data that is present in the primary memory, but CPU does not directly access the data present in the secondary memory. Next difference is power cuts cause data loss because it is a volatile. So whenever the power is off, the data will be lost. In case of secondary memory, even the power cuts, the data will not be lost. Then primary memory having less storage. The storage capacity is limited in the primary memory, and in the secondary memory the storage is expansive. We can have large storage space and expansive storage space. So in primary storage, faster data access. That means whatever the data present in the primary memory can be accessed very fastly compared to the secondary memory. The data present in the secondary memory will be accessed slowly. So these are the important difference between primary memory and secondary memory. Next, we'll see some of the basic concepts of memory. So these are also we have already discussed in the first unit itself. Let us recap once again. The main memory unit consists of million number of storage cells. Each cell can store a bit of information, either the value 0 or 1. So memory is organized in the form of an array, and the array contains large number of storage cells, and each cells we are going to store only one bit, either 0 or 1. The memory stores binary information in group of n bits is called a memory word. That means set of n bits that can be accessed in a single memory access operation. Memory access operation means it may be a read operation or write operation. So that is called as a memory word. A unit of 8 bits form 1 byte. That means the consecutive 8 bits is called as 1 byte. Next, the number of bits in each word is termed as word length. Word length refers to the total number of bits present in a word, that is word length. If 16 bits present means the word length is 16. If 32 bits present in a particular location, then the word length of that location is 32 bits. So it may vary from 16 to 64 bits. So depending upon the processor, the word length may be vary. Each word in the memory is assigned a distinct names called as memory address. ಸೊ ಈ ಒಂದು ಮೆಮೊರಿನಲ್ಲಿ ನಾವು ಮೆಮೊರಿ ವರ್ಡ್ಸ್ ಅಂದ್ರೆ ಏನು, 1 ಬೈಟ್ ಅಂದ್ರೆ ಏನು, ವರ್ಡ್ ಲೆಂತ್ ಅಂದ್ರೆ ಏನು, ವರ್ಡ್ ಲೆಂತ್ ಎಷ್ಟು ಬಿಟ್ಸ್ ಇರುತ್ತೆ, ಮತ್ತೆ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ಮೆಮೊರಿ ವರ್ಡ್ ಅಂದ್ರೆ ಒಂದು n ಬಿಟ್ಸ್ ಗ್ರೂಪ್ ನ ನಾವು ಮೆಮೊರಿ ವರ್ಡ್ ಅಂತ ಕರಿತೀವಿ. 8 ಬಿಟ್ಸ್ ಗಳನ್ನ ಗ್ರೂಪ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ 1 ಬೈಟ್ ಅಂತ ಕರಿತೀವಿ. ಹಾಗೆ ಒಂದು ವರ್ಡ್ ಅಲ್ಲಿ ಎಷ್ಟು ಬಿಟ್ಸ್ ಗಳು ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ವರ್ಡ್ ಲೆಂತ್ ಅಂತ ಕರಿತೀವಿ. ಈ ವರ್ಡ್ ಲೆಂತ್ 16 ಇಂದ 64 ಬಿಟ್ಸ್ ಒಳಗಡೆನೂ ಕೂಡ ಇರುತ್ತೆ. ಮತ್ತೆ ಆ ಮೆಮೊರಿನಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿರುವಂತಹ ವರ್ಡ್ಗಳನ್ನ ನಾವು ಆಕ್ಸೆಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ರೀಡ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಆ ಪ್ರತಿಯೊಂದು ಮೆಮೊರಿ ವರ್ಡ್ಗೆ ಒಂದೊಂದು ಅಡ್ರೆಸ್ನ ಕೊಟ್ಟಿರ್ತೀವಿ. ಅದನ್ನ ನಾವು ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅಂದ್ರೆ ಏನು ನೇಮ್ನ ಕೊಟ್ಟಿರ್ತೀವೋ ಅದು ಯುನಿಕ್ ನೇಮ್ ಆಗಿರುತ್ತೆ. ಆ ನೇಮ್ ಇಂದ ನಾವು ಆ ವರ್ಡ್ ನ ಆಕ್ಸೆಸ್ ಮಾಡಬಹುದು. ಸೊ ಅದಕ್ಕೆ ನಾವು ಮೆಮೊರಿ ಅಡ್ರೆಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ? ಓಕೆ. The maximum size of the memory in any computer is determined by the addressing scheme. So consider the computer having a memory and the address bits for that memory is 20. Then that having totally 1 megabytes of addressable memory location. That is, if the address bits is 20, then 2 to the power 20 is equal to 1 megabyte. The overall size of the memory will be 1 megabyte. And the next, suppose the address bits is 32, then 2 to the power 32 is equal to 4 GB. That means 32-bit address needed to uniquely address each of bytes present in the memory. In the same way, if the address bit is 40, then 2 power 40 is equal to 1 terabyte. The total capacity of the memory will be 1 terabyte. Next, the most modern computers are byte addressable. So nowadays there are so many computers are manufactured by the different companies, and those computers can follow in byte addressability. That means the byte locations have the addresses 0, 1, 2, 3, 4 up to 2 to the power k minus 1. So the size of the memory will depend upon the address bits. So if the k is the address bits. Suppose the k is equal to 4, then the memory size will be 2 to the power 4 minus 1. That means 2 to the power 4 is 16. 16 minus 1 is equal to 15. Then the location starts from 0 to 15. So overall 16 memory locations. There are two ways that the byte addresses can be assigned across a word. So byte addresses can be assigned in two different ways, that is big Indian arrangement and little Indian arrangement. So these also we have already discussed in the previous unit. So here we can see how the byte addresses are arranged. So here this is a big Indian assignment or arrangement, and this is the little Indian assignment. In big Indian assignment, the lower order byte are addresses from the most significant byte position. So this is MSB position, this is LSB position. So here we are going to assign the memory from the MSB byte position. So 0, 1, 2, 3. So this is 1 byte, this is 1 byte, this is 1 byte and this is 1 byte. So there are totally 4 bytes, that means 32 bits word length. And here the word address is same as the MSB position. So you can see this is 0, 0, 4, 4, next 8, 8, so on up to 2 power k minus 4 and 2 to the power k minus 4. And the 68000 Pentium processor can uses this arrangement. In Little Indian assignment, the lower order byte are addressed for the least significant byte of the word. So here we can see, here we are assigning the lower order byte in the least significant byte position. So this is the MSB position and this is the LSB position. So we are assigning from the LSB, rightmost side. So and here the word address is same as the LSB position. So 0044 2 to the power k minus 4. Here also 2 to the power k minus 4. So these two will be same. The Intel processor are using this little Indian arrangement. So big Indian arrangement can be used in the 68000 processors, and Intel processors are using the little Indian arrangement. Then one processor will be there, that is ARC processor, can be configured to use either of these arrangements. So ARC processor can use big Indian assignment as well as little Indian assignment. Okay. So this black diagram shows the connection of memory to the processor. So here we can see how the communication will occur between processor and the memory. A processor consists of so many components like MAR, MDR, PC, register set, ALU, etc. But here we are looking only on MAR and MDR. So MAR is a memory address register and MDR is a memory data register. MAR is used to hold the address and MDR is used to hold the data, and this is the memory. So this can contain 2 to the power k addressable location. So this depends upon the k bit, that is the address bus. So k is the address bit. So MAR is holding the address and it sends its address to the address bus, and MDR holds the data, and that data can be travel through this data bus. And we are having control lines, that is read slash write bar signal, and one more special signal, that is MFC, means memory function completed signal. So the data transfer between the memory and the processor takes place through the two processor register. So one is memory address register, that is MAR, another one is memory data register, that is MDR. If MAR is k bit long and MDR is n bit long, then memory unit may contain up to 2 to the power k addressable location. So the size of the memory is depends upon the number of the address bits. During a memory cycle, n bit of data are transmitted between the memory and the processor. So during the communication occurs between memory and the processor, in that time the n bit of data are transmitted between these two. Then this transfer takes place over the processor bus. So processor bus has address line, data line and control line. So address can be passed in the address line and data can be sent through the data line, and some special signals like read write signal and MFC can send through the control line. And this control line is used for coordinating data transfer. So next we'll see how the memory read and memory write operation will occur. So during the memory read operation, load the address of the required memory location into MAR and setting read write signal to 1. Memory responds by placing the data onto the data line and confirms by asserting MFC signal. Upon the receipt of MFC, the processor loads the data from the data line into MDR register. Same way, during the write operation, processor loads the address of the required memory location into MBR and data into MDR and setting read write signal to 0. The memory responds by placing the data from the data line onto addressed location. This confirms the action by asserting MFC signal. So you can see this communication in this diagram. So mainly two operation will be performed here. One is the read operation. Read operation means processor reads the data from the memory. Write means processor sends the data into the memory. So this concepts we have already discussed in the previous unit, that is operational steps associated with processor and main memory interaction. So now we'll recap the same thing once again. During a read operation, the processor read the data from the memory by loading address of the required memory location into MAR. So read the data from the memory. First, the processor loads the addressed memory location into the MAR and set read write line to 1. So this will be set to 1. After that, the memory responds by placing the data onto the data bus. Then it confirms by sending the MFC signal, that is memory will confirm to the processor by sending MFC signal, that is memory function completed signal. It is an acknowledgement to the processor to indicate that the required data is available on the data bus. Data bus is nothing but the data line. Finally, the processor loads the data in the data lines into the MTR. Now, the data is present in the data bus, and from the data bus, it will go and load to the MTR. So now, memory read operation will be completed. So ಇಲ್ಲಿ read operation ಹೇಗಾಗುತ್ತೆ ಅಂದ್ರೆ ಪ್ರೊಸೆಸರು ಅಡ್ರೆಸ್ನ ಮೆಮೊರಿನಲ್ಲಿ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ನ MAR ಅಲ್ಲಿ ಸೇವ್ ಮಾಡಿರುತ್ತೆ. ಆ ಅಡ್ರೆಸ್ಸು ಥ್ರೂ ಅಡ್ರೆಸ್ ಬಸ್ ಮುಖಾಂತರ ಮೆಮೊರಿಗೆ ಹೋಗುತ್ತೆ. ದೆನ್ ರೀಡ್ ಸಿಗ್ನಲ್ ಇಶ್ಯೂ ಆಗುತ್ತೆ. ಸೊ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ ದ ಡೇಟಾ ವಿಲ್ ಬಿ ರೀಡ್, ಅಂದ್ರೆ ಅಡ್ರೆಸ್ ಅಲ್ಲಿರುವಂತಹ ಡೇಟಾ ರೀಡ್ ಆಗಿ ಮೆಮೊರಿ ಆ ಡೇಟಾನ ಡೇಟಾ ಬಸ್ಸಿಗೆ ಕಳಿಸುತ್ತೆ. ಕಳಿಸಿ ಕನ್ಫರ್ಮೇಷನ್ಗೋಸ್ಕರ ಅದು ಮೆಮೊರಿ ಫಂಕ್ಷನ್ ಕಂಪ್ಲೀಟೆಡ್ ಸಿಗ್ನಲ್ನ ಸೆಟ್ ಮಾಡುತ್ತೆ. ಆ ನಂತರ ಡೇಟಾ ಬಸ್ ಅಲ್ಲಿರುವಂತಹ ಡೇಟಾ ಪ್ರೊಸೆಸರ್ ಇಲ್ಲಿರುವಂತಹ MTR ರಿಜಿಸ್ಟರ್ ಅಲ್ಲಿ ಹೋಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಸೊ ಹೀಗೆ ರೀಡ್ ಆಪರೇಷನ್ ನಡೆಯುತ್ತೆ. Next we'll see how the write operation will take place. The processor writes the data into the memory location by loading the address of memory location into MAR and load the data into MDR and setting read write signal to 0. If read write signal is 1 in the read operation, and during write operation read write circle will set to 0. Then the memory responds by placing the data from the data line onto the addressed location, and then memory confirms this action by sending the MFC signal, that is memory function completed signal. ಸೊ ಈ ರೈಟ್ ಆಪರೇಷನ್ ಹೇಗಾಗುತ್ತೆ ಅಂದರೆ ಪ್ರೊಸೆಸರು ಯಾವ ಒಂದು ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಅಲ್ಲಿ ಡೇಟಾ ಸೇವ್ ಆಗಬೇಕೋ ಆ ಅಡ್ರೆಸ್ನ MARಗೆ ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. ಹಾಗೆ ಯಾವ ಡೇಟಾನ ಸ್ಟೋರ್ ಮಾಡಬೇಕೋ ಅದನ್ನ MTR ಅಲ್ಲಿ ಅದು ಸ್ಟೋರ್ ಮಾಡುತ್ತೆ. ನಂತರ ರೀಡ್ ರೈಟ್ ಸರ್ಕ್ಯೂಟ್ ಸೆಟ್ ಟು 0 ಆಗುತ್ತೆ, ಅಂದ್ರೆ ರೈಟ್ ಸಿಗ್ನಲ್ ಇನಿಶಿಯೇಟ್ ಆಗುತ್ತೆ. ಸೊ ರೈಟ್ ಸಿಗ್ನಲ್ ಇನಿಶಿಯೇಟ್ ಆದ ತಕ್ಷಣ MTR ಅಲ್ಲಿರುವಂತಹ ಡೇಟಾ ಯಾವ ಅಡ್ರೆಸ್ ಕೊಟ್ಟಿರ್ತೀವೋ ಆ ಅಡ್ರೆಸ್ ಅಲ್ಲಿ ಹೋಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಸ್ಟೋರ್ ಆದ ನಂತರ ಮೆಮೊರಿ ಫಂಕ್ಷನ್ ಕಂಪ್ಲೀಟೆಡ್ ಅಂದ್ರೆ MFC ಸಿಗ್ನಲ್ ನ ಸೆಂಡ್ ಮಾಡೋ ಮುಖಾಂತರ ಆಪರೇಷನ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಅಂತ ಅದು ಒಂದು ಸೂಚನೆಯನ್ನ ಕೊಡುತ್ತೆ. ಸೊ ಹೀಗೆ ರೀಡ್ ಮತ್ತೆ ರೈಟ್ ಆಪರೇಷನ್ಸ್ ಆಗುತ್ತೆ. ಸೊ ಎಲ್ರಿಗೂ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. Next is speed of memory units. So first is memory access time. It is the time that elapsed between initiation of a memory operation and completion of that operation. So access time is nothing but the amount of time it takes the processor to read the data from the memory or amount of time it takes the processor to write the data into the memory. Time between read and MFC signal. ಅಂದ್ರೆ ಪ್ರೊಸೆಸರು ಮೆಮೊರಿಯಿಂದ ಡೇಟಾನ ರೀಡ್ ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು ಸಮಯ ತಗೊಳುತ್ತೋ ಅಥವಾ ಪ್ರೊಸೆಸರು ಡೇಟಾನ ಮೆಮೊರಿಗೆ ರೈಟ್ ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು ಸಮಯ ತಗೊಳುತ್ತೋ ಆ ಒಂದು ಟೈಮಿಗೆ ನಾವು ಮೆಮೊರಿ ಆಕ್ಸೆಸ್ ಟೈಮ್ ಅಂತ ಕರಿತೀವಿ. Then memory cycle time. It is the minimum time delay that required between the initiation of the two successive memory operations. So the time delay between any two successive memory operations. So it may be read operation or write operation. That is called as a memory cycle time. This cycle time is measured in nanoseconds. The memory cycle time is always greater than the memory access time. So cycle time access time ಗಿಂತ ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಆಗಿರುತ್ತೆ. Other forms of memories. Actually, we want the memory to be fast, large and less expensive. But we cannot have all these in one. So to satisfy all these requirements, we need different kinds of memories. So that is cache memory and virtual memory. So the cache memory is nothing but, so it is one of the way to reduce the memory access time to use we are using the cache memory to reduce the memory access time. And cache memory is a small, fast memory that is placed in between the larger, slower main memory and the faster processor. Cache holds currently active segments of a program and their data. That means cache is a very small memory and it is a fastest memory that can be placed between main memory and the processor. Suppose if the processor wants any data, it will directly access from the cache memory. If any instructions or data is not present in the cache memory, then only it will going to take from the main memory. That's why the operation will be faster and it is very a small memory. Next, cache holds currently active segments of a program and their data. So this is the important functions of the cache memory. And the next is virtual memory. Virtual memory is a method of using the computer hard drive to provide extra memory for the computer. In the virtual memory, the physical memory is nothing but the hard disk will be treated as the logical memory. If the computer does not have sufficient main memory, then it uses some other memory from the external disk as a primary memory. So that is treated as main memory by the operating system. ಸೊ ಯಾವಾಗ ನಮಗೆ ಮೇನ್ ಮೆಮೊರಿನಲ್ಲಿ ಸ್ಟೋರೇಜ್ ತುಂಬ ಕಡಿಮೆ ಇರುತ್ತೋ ಆವಾಗ ನಾವು ಎಕ್ಸ್ಟರ್ನಲ್ ಮೆಮೊರಿನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಆ ಒಂದು ಎಕ್ಸ್ಟರ್ನಲ್ ಮೆಮೊರಿ ಪ್ರೈಮರಿ ಮೆಮೊರಿ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ ಮತ್ತೆ ನಮ್ಮ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಅದನ್ನ ಮೇನ್ ಮೆಮೊರಿ ಅಂತಾನೆ ಟ್ರೀಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ವರ್ಚುವಲ್ ಮೆಮೊರಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದೀಸ್ ಟೂ ಆರ್ ದ important forms of memory. So to increase the size and to increase the operation speed, we are going to use these two memory. So next, we'll discuss some of the important multiple choice questions on these topics. The first question is the length of word may be specified as n bits per word called dash of the computer. The options memory location, memory word, word length and none of the above. So the solution is memory word. Second question, if a system is 64-bit machine, then the length of each word will be dash. Option A 4 bytes, option B 8 bytes, option C 16 bytes and option D 12 bytes. The solution is 8 bytes. 8 into 8 is equal to 64 because 1 byte is nothing but 8 bits. Next question. The memory unit stores information in group of n bits called dash. The solution is memory word. Next question. In Big Endian, dash addresses are used for the most significant bytes of the word. Option higher order byte, lower order byte, can't say, none of the above. The solution is lower order byte. Next question. Dash is the minimum time delay that required between initiation of two successive memory operation. Options memory access time, latency, memory cycle time, none of the above. The solution is memory cycle time. Next question. Any electronic holding place where data can be stored and retrieved later whenever required is dash. Answer memory, drive, disk, circuit. The answer is memory. The next question. The memory implemented using the semiconductor chip is dash. Option cache, main memory, secondary and register. The solution is main memory because the main memory is made up of semiconductor materials. Next question. Size of dash memory mainly depends on size of the address bus. Option main, virtual, secondary, cache. The solution is main memory because the address bits, based on the address bits, we are saying the size, we are finalizing the size of the memory. Next question. Storage which stores or retains data after power off is called volatile storage, non-volatile storage, sequential storage, direct storage. The solution is non-volatile storage because non-volatile memory will retain their data even the power is switched off. So the solution will be non-volatile storage. The last question is virtual memory consists of option static RAM, dynamic RAM, magnetic and none of these. The solution will be static RAM. I hope you all understand these topics very well. Now we are in the last part in this session, that is conclusion part. So in this session we have discussed on memory. So here we have discussed what is the meaning of the memory and the different types of the memory and different names of the memory, and we have already discussed some of the important difference between primary memory and secondary memory. Then some basic concepts of memory system. Here we have discussed memory word length, byte and memory address. Then we have discussed about connection of memory to the processor. Here we have discussed how the read operation and write operation will perform. And finally, we have discussed the different forms of the memory, that is the cache memory and the virtual memory. So these are the topics we have discussed in this session. I hope you all understand these topics very well. So if you have any extra information, or if you want any extra things, or if you have any clarifications, any doubts, and for the more information, you can look into the textbook, that is Computer Organization by Carl Hamcher, Zwanko Rancic and Zafar MC Grahil, 5th edition. And this is the team which is responsible for developing the content on computer organization. Thank you for watching this